4 added to a number is 14. So 4 added to, and then for a number, wherever it says that, that's where your variable goes. We'll use x. Is the equal sign. What's x, guys? 10. Pretty much 10. Okay, 7 times a number. So 7 times x, because wherever it says a number, that's where you put your variable in. Does it say squared? A number squared is 28. Hey, what's x? 2. 2 plus the quotient of a number and 8 is the same as 16. What's x? Yeah, just one. Yeah, when x is 112. Good job. All right, so you need a separate piece of paper for your bell work quiz. You're going to turn it in. You know, I almost didn't put these desks into groups because I don't want you to cheat, but I'm just gonna. So in an equation, the left side and the right side are the same. That's what makes them equal. So as long as if you're gonna add 4 to the left side of an equation, like if you were measuring grapes or whatever, if I put 4 grapes on my left hand, I have to put 4 grapes on my right hand, and that equation still equals. And that is the addition property of equality. See that here? It says use the addition property of equality to solve each equation. So let's just write that property to the side here. Whatever you're going to add to one side of an equation, you must add to the other. And so that's just something to keep in mind throughout math. Whatever I do to one side, I have to do to the other. So we're going to solve one-step equations. There's a big blank here for you to write one step. Sorry, can you still see that? We want to solve equations without a replacement set. So we were doing work with replacement sets, plugging in a whole bunch to figure out what variables are. And now we're gonna figure it out without it. Can anybody in letter A figure out what H is? What would H be to make it equal negative 27? What minus 12 would equal negative 27? Go ahead. Negative 15 minus 12 is negative 27. So some people are going to look at that and figure that out. It's a one-step equation. When equations get longer, multi-step equations, it's much harder to look at it and figure out. So we're going to use a process to figure out what h is. I want to have h alone. Let's set our goal as getting a variable alone. My goal is to isolate the variable given. And so I have h here. And what's with h is a minus 12. And that minus 12 is like hard in my way. So I'm going to cancel it out. What is the opposite of subtraction? Addition. So I'm going to add 12 here. And I'm going to consider the property of equality. If I add 12 here, I also have to add 12 on the other side of the equal sign, and my equation is still going to be true. So what I'll be left with is h, negative 12 plus 12 cancels, so they're gone, equals, and I'm not very good with negatives, so maybe I'll consult a calculator, negative 27 plus 12, negative 15. So some of y'all are doing this already in your head and you were able to say that's negative 15. But using the property of equality and just adding the 12 to both sides will just give you that number. Let's try it again in letter B. I see G. I'm going to put a line through the equal. I really would love for G to be by itself. So what do I have to do to cancel out a minus 15? Let's plus 15 to both sides. And now the 15's gone, G is by itself, and I can see what G is. G is 140. It's really, really good to have this base before we get into longer equations. Patrick, what's G in the next letter A? What? Take away 25 is 113. And that's going to help us figure it out. Rather than just sitting and thinking mentally, what could this be? We're just going to cancel this 25 out. We don't want it here. We're canceling it. We'll have to add it to both sides so that our equation stays balanced. The 25's are gone, and I can see now that G is 138. Is this big enough up here? It's kind of hard to see. All right, I've located J here. I want J to be by itself. What do I do to get J alone? Yeah, I'm on the second letter B. Plus 87. Was I saying G instead of J? No wonder. Negative 3 plus 87. Logan, what's that? 84. Now I know what J is. It's 84. All right, so now we're going to do the subtraction property of equality. Maybe we won't rewrite it. Whatever is subtracted from one side must be subtracted from the other side. So I'll locate my variable here, it's h. Put my equal line in. H is not by itself. I really want to get H alone. What are we going to do? Because it's a plus 12. So if I don't want that 12 there, I'm going to cancel it by doing a minus 12. And if I minus 12 here, I also minus 12 on the other side. That's the property of equality. The 12s are gone. What's negative 27 take away 12? Somebody else. Alright, here's the next 3 in your groups.
Oh, I look at the bottom. Next 3, so that means. Oh, okay. Yeah. So we're gonna do.
Is this 66? What's B? Yeah. What I just did. What is C? So if you guys didn't show this work, you're not getting credit. I don't want to know that you can look at it and figure it out. I want to know that you know the property of equality. That what you do to one side, you do to the other side. So this is, a lot of you guys can just look at it and figure out what P is. I'm not testing you on that. I'm testing on do you understand the property of equality? So show your work. What are you doing to the left side and what are you doing to the right side? All right, did everybody get these values here? With your properties of equality? All right, so the multiplication property of equality or the division property of equality, same concept. Whatever you multiply or divide from the left, you have to multiply and divide from the right. Yeah, this one looks way more difficult. So let's rewrite this first fraction as a improper fraction instead of a mixed number. So I'm changing this instead of 1 3/8 to negative 11 over 8 because you have 8/8 and 3/8 would make 11/8. Well, 1 is 8 over 8. So now I need to get this k alone. Just pretend the problem started like that. So what property will cancel out a fraction? Multiplicative inverse. We're going to use the multiplicative inverse here. I ran out of room. Hopefully you're good. So if I want k alone here, we're going to multiply by the reciprocal. multiply by reciprocal to isolate k. So the reciprocal will be negative 8 over 11. Because this would be negative 88 over 88. Well, negative times a negative would be positive. So this is now a positive 1. It's a positive 1k equals 2 times 8, 16. 3 times 11, 33. We don't need that 1 in front. So this is the fraction we're looking for. What's that? I don't think, 33 doesn't divide by 4, or 8 or 2. So. Okay, so sometimes you have to multiply by reciprocal to get rid of a fraction there. Letter B. This is 15 times B. What's the opposite of multiplying by 15? So we're going to do opposite operations. We're going to divide by 15 to cancel 15 out on both sides of the equal line. No, we're going to take it with us. Divide negative 15. Then we cancel the 15s, but the b stays where it's at. We're going to leave b alone. I think it's positive 5. Positive 5. And you can always plug back in to check. All right, Joseph, what's our strategy here? How are we going to get k alone? Multiply by the reciprocal on both sides of the equal line. So the reciprocal will be 5 over 3. The fractions cancel. 6 times 5 is 30. Denominator of 3. Turns out k is 1. 10. K is 10. That was unexpected. All right, how do we get b alone in this next one? And so those fractions are gone. Over here, 3 times 1 is 3. 2 times 4 is 8. Negative 3 equals 3. All right, go ahead and try the word problem in your groups.
Okay, the cargo is walking 780 miles an hour.
X plus 35? X plus 35.
Sounds about right.
Oh, we got the answer.
What's 780 times 3, Mikhail?
Yeah.
This isn't a flipping situation. Because he's trying to go 780 total. And he's only been 3/5. So 70/80 times 3/5 is going to give us our distance that he drove. But I'm not confident in my number.
I got 468.
That's what we got.
No, it's 780 times 3.
Oh, I had it right. I did have it right. Just need someone to back me up. Okay. So, and then so what's the final answer when you divide by 5? So let's answer in a complete sentence. Ricardo drove 468 miles. How is that 3/5? Oh yeah, that makes perfect sense. Just over half on the first day. Yeah, that's a long drive. Long drive.
68 miles.
I could run that much easily.
Did you say you could run that much? I'd like to see you try Usain Bolt.
Allison is making a stained glass window. Her pattern requires that 1/5 of the glass should be blue. She has 288 square inches of blue glass. If she uses all of her glass, how much glass will she need for the entire project? Oof. Okay, so I'm going to do glass times 1/5 equals the amount of blue glass. Everybody with me there? 1/5 of the total glass should be blue. And they're telling us how much blue we have. So glass times 1/5 is 288. So how much total glass does she need? How do we solve for G here? How do we get G alone? Reciprocal, 5/1 on both sides.
Mm-hmm.
1,440 square inches is what I'm hearing. Let's do a sentence. Allison needs 1,440 square inches of glass total in all her colors. And Allison sounds really cool. Stained glass is really neat.
She does sound pretty cool.
Or she just doesn't have the same.
She really learns that stuff a lot.
Now you can just buy that face gun stuff at Ace Hardware. Yeah, I think she does. That's what I envisioned for Allison. She's on Etsy. She's making stained glass windows for people. All right, you have homework, so write it down and try your best at it.